Welcome to my video. My name is Rahul and you're watching Learn with RP Sir Mtech JU. And in this video, we are going to learn about an application of partial fractions. In the previous video, we have already discussed one application which was on the linear distinct denominators, like linear distinct factors. And now we will be discussing another example of partial fraction, which is on linear equal factor combined with linear distinct factor. So when this kind of case comes in partial fraction, how we are going to deal with this question, let us find out. So as you can see here in front of you, there is a question where there is x plus 1 whole square in the denominator, which is an example of linear equal factor because it's x plus 1 and x plus 1. And then we have x plus 3, which is an example of linear distinct factor compared to x plus 1. Now, what is linear distinct factor? What is linear equal factor? If you are not able to understand, so I have already made a video on the partial fraction theory. I would request you to go and watch that video first, and then you will be able to understand the whole terminologies, like what is linear distinct factor, what is linear equal factor. So please watch the theory first and then come to the application. It will be a lot easier for you to understand the particular video, and I have step by step explained every single thing on that particular video, so please go and watch it. So now when you have watched that particular video and when you have come back, so see how this question is going to be done. So we will start with forming the partial fraction of this particular expression. So how we are going to do it? See, so first 3x minus 2 over x plus 1 whole square and x plus 3. So we are going to write the partial fraction of this. So we will start with a over x plus 1 plus b over x plus 1 whole square. That is how we write the partial fraction for equal factors. And then for this one, x plus 3. This is for the linear distinct factors. So now we are going to make the denominator same. So 3x minus 2 over x plus 1 whole square times x plus 3, and this side we have again the same denominator, x plus 1 whole square times x plus 3, and here we will be getting a times of x plus 1 and x plus 3 plus b times of x plus 3 plus c times of x plus 1 whole square. So now if I remove the denominators, now that the denominators are equal, it can be eliminated. So we will get the final expression which we will use in order to find the value of a, b, c. So this is a x plus 1 times x plus 3 plus b x plus 3 plus c x plus 1 whole square. So this is the final product. This is the final product that we have got. Now we are going to solve this by putting different values of x and finding the variables a, b and c. I mean the constants a, b and c. So first of all, we have to find such values of x so that two of the constants get eliminated and the third constant stays. For example, if I put x equal to -1, so this particular factor will be 0, which means this constant will get eliminated because 0 multiplied by anything is 0. Now this particular factor will also be 0 when I put x equal to -1. So c multiplied by 0 will also get eliminated, which means that only b will remain. So this is our first experiment. We will put x equal to -1. So when we put x equal to -1, so see what happens. So this is 3 times of -1 minus 2, which is -3, -2, which is -5. This gets eliminated, this gets eliminated, only left with b times of -1 plus 3, which is nothing but 2, which gives you b equals to -5/2. So this is the value of b that we are getting. Now again, if I put x equal to -3, again a gets eliminated, but this time c stays and b gets eliminated. A gets eliminated because x is -3, so 3 minus 3 will become 0, and a times of 0 is 0. Similarly, 3 minus 3 will become 0 in case of the second one also. B times 0 is also 0. So c will be remaining. So if I put x equal to -3, so this is -9 and -2, so this is -11, and here a will get eliminated, b will get eliminated, meaning c will stay, and this is -3 plus 1, which is -2, but it's a square, so it will become 4. So what is c? C will be equal to -11/4. That is the value of c. So b and c we have already got. Now we have to find out what is the value of a. So for doing that, let us take any random value of x, because whatever we take, a will be eliminated. So we cannot take any particular value for which the factors will be 0. So we have to take one random value of a. So let us take x equal to 0. So if we take x equal to 0, so it will be let's say 3 times of 0 minus 2, which means that this will be -2. Now in this particular case, a will be a times of 0 plus 1 and 0 plus 3. So 0 plus 1 will give you just 1, and 0 plus 3 will give you just 3. So this will be times 3. So I can say just this is 3a, right? 0 plus 1, 0 plus 3 and a, so this is 3a. Okay, plus b. B is what? B is -5/2 times of 0 plus 3, so it will be just 3, and plus c is -11/4 plus 0 plus 1 whole square, so it will be just 1. So now we have to solve this thing. So -2 is equal to 3a, and this is -15/2 minus 11/4. So we have to take the numbers on the other side and add it with -2, and 3a's will stay on one side. So we can write 3a is equal to 15/2, which can be written as 30/4. Now why am I doing 30/4? So that I can make the denominator same, easy to calculate on my point of view. So there are different ways of calculating fraction addition, so it's completely up to you. In normally what I do is I make the denominator same, so it becomes very easy to calculate. So 30/4 I have made, plus 11/4, and this -2 will stay -2, so you can make it 8/4 also, you can make -8/4, right? So the total gives you 30 plus 11 is 41, and 41 minus 8, so 40 minus 8 would have been 32, so 41 minus 8 would be 33/4. Okay, 41 minus 8, yeah, let me just calculate once. 30, 40, 41 minus 8, yeah, 33/4. So from here we can deduce the value of a will be equal to 33/4 divided by 3, which is 11/4, positive. So this is one conclusion, this is one conclusion, this is another conclusion. So the values we have already figured out. Now we are going to simply solve the problem. So we will write it in this format. So a Since it's a constant, will stay outside. So it will be a integration dx over x plus 1 plus b integration dx over x plus 1 whole square plus c integration dx over x plus 3. So this is the process. So now dx over x plus 1 is simply logarithm of x for x plus 1. So it will be a logarithm of x plus 1. We'll put a on the last, plus this one. Now see, this is x plus 1 square. So if you put it on the top, it will be to the power of -2, which is in the format of integration of x to the power of n dx. Integration of x to the power of n dx is given as x to the power of n plus 1 over n plus 1. This is the formula plus c. So if I apply this particular formula, so see here what is going on. So this will be x plus 1 to the power of -2 dx. So this will be b times of x plus 1 to the power of -2 plus 1 over -2 plus 1, and plus c, this is again log of x plus 3. Okay. Now here one more line I'll attach, a log of x plus 1 plus, okay, now minus, because -2 plus 1 is -1, so this minus will stay, minus b x plus 1 to the power of -1, which means it will be 1 by x plus 1 plus c logarithm of x plus 3 plus c. So now let us put the values. So the value of a is 11 by 4 log of x plus 1. Now minus b, so b is -5 by 2, so minus b will be plus 5 by 2, and the x plus 1 will be in the bottom, and plus c is -11 by 4 logarithm of x plus 3 plus c. Okay, this you can keep it as the final answer. We can simplify even more. Let's say if I take 11 by 4 as common, so you can write here logarithm of x plus 1 minus logarithm of x plus 3, and then the rest 5 by 2 times x plus 1 plus c. So finally what we get is, so see, log of m minus log of n is log of m by n. This is a logarithm rule. So 11 by 4 log of x plus 1 over x plus 3 plus 5 over 2 times x plus 1 plus c, and this is the final answer. Okay, this is the final answer to the problem. So I hope you have understood all the steps that we have discussed. First of all, we are going to break it down in the partial fraction format. Next, we are going to make the denominator same, and in the process find out what is the numerator. Then once we have devised that particular equation, now we are going to find ways to find out the values of a, b and c. Upon finding the values, now we are going to put them as constants, and we are going to solve it in the same format in which we have arranged the partial fraction, and then we will get the desired result. So that is the process in which we are going to solve this entire equation. So If you have understood the video and if this video was helpful for you, I would request you to please subscribe my channel, and yes, please share this video with your friends who might need a help on this particular thing in calculus, because it's a very important and critical topic at the same time. So anyways, I'll see you with some more videos. Until then, take care and have a good day.